Welcome to Mikab Model College online tutorial. We hope at the end of this lesson, you will have acquired the expected learning outcome. Sit down and listen attentively as we introduce your subject teacher.
Welcome back to another chemistry class. I am Saliu Abdul Wahab. Now, as a kind of reminder, in our previous class, we discussed the properties of matter. And then we said that matter exhibits two types of properties, physical properties and chemical properties. And in the chemical properties, we said that based on the chemical properties of matter, matter is divided into three classes: elements, compounds, and mixture. This takes us to a new topic now: elements, compound, and mixtures. Elements, compounds, and mixture. Now let us start with an element. What is an element? An element is defined as any substance that contains only one type of atom, only one kind of atom. Of course, an element cannot be split by any chemical means or by any physical means. An element exists as a single entity. It cannot be split by any means at all, whether by chemical means or by physical means. Now, let us see. There are several examples of elements. Several examples of elements. Now, those elements ranges from hydrogen, helium, lithium, oxygen, carbon, chlorine, argon, calcium, iron, and so on and so forth. Of course, there are several types of elements that has been discovered, and yet there are some that are left undiscovered. We have 118 elements known in the world. Of these 118 elements, 94 out of them exist naturally. They exist naturally, while the remaining 24 are synthesized. The remaining 24 are man-made. However, some of these elements are stable on their own, and some are not stable. They can easily decompose. And those ones that are not stable, they exhibit isotopic forms. And some of those elements that are not stable are used as radioactive elements. They are used as radioactive elements. However, all elements are represented by chemical symbols. All elements are represented by use of chemical symbols. What are chemical symbols? Chemical symbols are letters that are used to represent an element. Chemical symbols are letters that are used to represent an element. All elements are arranged in a table known as the periodic table in a systematic manner based on their increasing atomic numbers. Now, elements in the periodic table are not written in their full form. They are written in their short form using symbols to represent them. Now, on this note, let us look at some of these elements, how they are classified. All elements are classified based on the properties that they exhibit. Of course, there are three classes of elements. There are three classes of elements based on their properties. The three classes of elements are metals, number 2, non-metals, and number 3, metalloids. Now, all elements, whether metal or non-metal or metalloid, they are systematically placed in a table known as the periodic table. Of course, what are metals? Metals are chemical substances that ionizes by losing their valence electron. And when we say valence electron, we mean outermost electron. Immediately after electronic configuration, the number of electrons left at the outermost shell is referred to as the valence electron. All metals ionizes to lose this valence electron. Examples of metals are sodium, potassium, magnesium, aluminium, copper, zinc, iron, and so on and so forth. They all ionizes to lose their valence electron, and they still possess some kind of quality again that makes them metal. For instance, they are ductile, they are sonorous, and of course they have high boiling points, and so on and so forth. The next class is the non-metal. They are elements, all non-metals are elements that ionizes to gain or accept electrons. Remember that if metals are losing electrons, the non-metal stands to accept those electrons. Therefore, all metals are electron donors, while all non-metal are electron acceptors. Now, the example of the non-metals are the chlorine, fluorine, iodine, bromine, argon, oxygen, and so on and so forth. Now, let us take a look at the metalloids. The metalloids are in between metals and non-metals. Now, metalloids are chemical substances that possesses the properties of both metals and non-metals. They possess the properties of metals and non-metals. An example of the metalloid is graphite. Graphite is an allotrope of carbon. Diamond is also an allotrope of carbon. Of course, diamond cannot conduct electricity. Graphite can conduct electricity. Diamond will be representing a non-metal, while graphite will be representing a metal. Therefore, you will discover that inside this carbon, diamond and graphite possesses both the properties of metals and non-metal. Hence, it is referred to as a metalloid. Another example is silicon. It has the properties of both metal and non-metal. Now, as a way of getting it again, we need to understand that all metals are electron donor, while all non-metals are electron acceptors. Of course, metals are very hard, while non-metals are not hard. However, there are some metals that are not hard. Sodium is not hard. Potassium is not hard. They can easily be cut, even using a small knife. Therefore, let us not mistake it when we say that metals are hard. Remember, sodium and potassium are not very hard. They are very, very soft. Yet, they are metals. Why? Because they ionize by losing their valence electron. All elements are made up of tiny particles. These tiny particles are called atoms. However, two or more elements, such as metals and non-metal, such as metals and metalloids, such as non-metal and metalloids, may combine together in a definite ratio to form what is known as compound. Therefore, when metals combine with metal, a compound is formed. When a non-metal combines with a non-metal, a compound is formed. When a metalloid combines with a metal, a compound is formed. And when non-metal combines with non-metal, a compound is still formed. But then, there are differences between the compounds that will be formed. Of course, when a metal and a non-metal combine, ionic compound is formed. Example, sodium chloride, table salt, common salt. Is a combination of sodium and chlorine. Sodium is a metal, while chlorine is a non-metal. When the two combine, of course, an ionic compound is formed, of which the sodium carries a positive charge and the chlorine carries a negative charge. Now, when a non-metal combines with another non-metal, take for instance, when carbon combines with hydrogen in definite ratios. For instance, one carbon combines with 4 molecules of hydrogen, one atom of carbon combines with 4 molecules of hydrogen, of course, methane will be formed. A non-metal combining with another non-metal. In case like this, a covalent compound will be formed. A covalent compound will be formed. Take note, when metal combines with non-metal, an ionic compound is formed. When a non-metal combines with another non-metal, a covalent compound is formed. Another example is a combination of carbon, hydrogen, and oxygen under certain conditions in definite proportions and ratios to form what is known as glucose. Glucose is going to be a covalent compound. Glucose is going to be a covalent compound. Now, I want you to know that elements are chemical substances that cannot be split by any means, either physical means or chemical means. There are 118 known elements, 94 are naturally occurring, while the remaining 24 are synthetic, man-made. Of course, elements can either be metal, non-metal, or metalloids. And when these elements, either metal combining with metal, non-metal combining with non-metal, metal combining with non-metal, compounds will be formed. But depending on the combination that will determine the type of compound that will be formed, either an ionic compound or a covalent compound. Remember that all metals are electron donor and all non-metals are electron acceptors, while metalloids are substances that are intermediate. They are in between metals and non-metals. They have the properties of metal and the properties of non-metal. Thank you very much. See you in the next class.